There are exactly 2 space stations in orbit around planet Earth right now. One of them you will have heard of, the International Space Station. But what about the other one? Tiangong, or the Heavenly Palace, is the 3rd in a series of space stations launched and maintained by the People's Republic of China. It has been in orbit since 2021, yet Western media reports much less on what happens aboard this 2nd, enigmatic bastion hanging in space's expanse. So, what is going on up there? I decided to look into it. And when I found the list of their past and current experiments, and as I pieced together what it meant, the sheer scale of China's ambitions stunned me. We are familiar with the sorts of things being done on the ISS, experiments aimed at better understanding how humans might adapt to space environments and uncovering the mysteries of our universe and its physics, inevitably general in scope, reflected in the differing priorities and the emphases of each nation collaborating within it. But inside Tiangong, the goal is more focused. What is the goal? That's what you're about to find out. I'm Alex McColgan, and you're listening to the Astrum podcast. Join with me today as we uncover the goings-on within Tiangong Space Station and discover what implications this might have on the future of humanity in space. Unlike the ISS, which has been in orbit for over 25 years, China's own space station endeavors only started in 2011 with the launch of the first Tiangong space station. That's right, they launched the whole space station in one go. This was not a complex construction. Tiangong 1 was a simple tube-like prototype consisting of a sleeping and living station for Chinese astronauts, otherwise known as taikonauts, a habitable lab for docking and orbital experiments, and a module for propulsion. The whole station was only 10.4 meters long compared to the ISS 108 meters and had 2 solar panels on either side. Its simplicity was a reflection of China's purposes for it, to master rendezvous and docking techniques, and to only dip their toes in the water of space habitation. Tiangong 1 was only in space for a little under 7 years. China did succeed in sending both crewed and uncrewed missions to Tiangong 1, and buoyed by this success, they upped their game with plans for a larger space station. To achieve this goal, more tests would be needed. In 2016, a second space station was launched, which also bore the name of Tiangong. Tiangong 2 was intended to field test key technologies that would be needed for the larger space station, and was deorbited just a few years later in 2019 once its tasks were completed. The road was paved for China's Tiangong 3. Tiangong 3, often referred to as just Tiangong, aims to be the home of thousands of experiments. To further this goal, Tiangong consists of the Tianhe core module for crew to live in, and 2 science modules emerging from either side, Wentian and the Mengtian. The former designed to see space's impact on living things and to develop medical technologies, while the second focused on microgravity and its effects on fluid behavior, combustion, and more. Rotating solar panels connect to the station and turn to face the sun, allowing Tiangong to maximize its energy collection. The Tiangong has an external robotic arm that can carry a taikonaut to various parts of the station, allowing extravehicular activities to be carried out. The whole cross-shaped station weighs 100 tons and is 55 meters long and can house up to 6 taikonauts at once, smaller than the ISS, but still large enough that it had to be assembled module by module in space, with modules launched between 2021 and 2022. Life on board the Tiangong is in many ways similar to life aboard the ISS. China tries to keep its taikonauts happy with a wide range of space foods, 120 different kinds. Naturally, given the muscle atrophying effect of microgravity, it's important for taikonauts to spend time each day exercising, or else they'd have a very bad time of things when they came back to Earth. Similar to the ISS, one of the main aims of the Tiangong space station is the popularization of science. So taikonauts spend some of their time taking part in presentations and collaborations with schools in China. For instance, they ran a demonstration involving what fire looks like when there's no gravity. Students are also involved in growing rice seeds from the same batch of seeds growing on Tiangong, which will help Chinese scientists explore the impacts of microgravity on plant growth. Tiangong is home to several live plants, although some care has to be taken while watering them. Nothing so far here is too much out of the ordinary. However, there is a theme to the experiments being carried out on Tiangong over the course of its 15-year lifespan. 5 themes, in fact, that all point to a truly ambitious goal. The 5 research themes are on-orbit assembly and construction technologies in space, robotics and autonomous system technology, new energy and propulsion technology, environmental control and life support system technology, and new generic technology for spacecraft. The technical terminology can make things a little murky, so let's break down what each of these means. Even just the first of these areas of research is awe-inspiringly ambitious. By on-orbit construction technologies in space, we're talking about developing all the technology necessary to build large space facilities or even spacecraft. In a paper released in 2023, Chinese scientists laid out their goal to develop 3D printing capabilities and other manufacturing tools in orbit. They're already some of the way there. In 2018, they pioneered the first technology to 3D print ceramics under microgravity, which is appropriate for the nation that was one of the first to work with that material 10,000 years ago. Their desire to pursue this goal makes a lot of sense. Getting parts into orbit is a tricky proposition. The Tiangong space station itself had to be built over the course of several launches, with great costs involved and with risk to delicate systems every time a module was launched. Imagine how much easier it would be if you could simply send raw material up and have it processed and manufactured into usable parts in space. Or even better, to use extraterrestrial materials already up there. The idea is certainly logical, but from the Tiangong's mission goals, it's clear that this has gone beyond the idea stage in China. They are looking for ways to implement it. The paper also describes inflatable scalable structures in space that could then be used as a habitat on neighboring bodies. These lightweight habitats, effectively tents on the moon, would be easy to transport, but aren't limited to the moon. More on that later. Robotic systems would go hand in hand with this. The manufacturing industry back home on Earth greatly benefits from robotic assembly lines. Chinese scientists and engineers are looking at ways robots can perform tasks in space, such as repair work, construction, cargo transfer, and more. Taikonauts are already laying the groundwork by testing robots and their ability to perform in microgravity, running robots through pipes and other exercises. But it goes further than just plans for Earth orbit or even the moon. The next research area looks towards developing new forms of energy and propulsion systems. Solar panels are a great way to get electricity in space. However, China is looking into other options, likely because once you get out to the ranges of planets like Jupiter, sunlight is no longer strong enough. NASA's Juno mission is the furthest spacecraft to use solar panels to date, as I talk about in another of my videos here. But by that distance from the Sun, light levels drop to just 3% of what we get here on Earth. Hardly enough to support large projects out at that distance. And what this implies is that China is considering large projects at that distance, especially when combined with their aim to create efficient propulsion systems with a long operating life. Any rocket fuel propulsion system can get heavy on long trips, as you have to carry all the fuel you use, unless you can develop it in situ. Due to these increasing logistical costs, outposts that are self-sufficient are incredibly valuable, which is why taikonauts are also actively exploring ways to recycle oxygen, water, grow food, prevent microbial problems, and harmless degradation of waste. This is one of the reasons taikonauts are experimenting growing rice in space. They're also performing studies on the effects of microgravity on living organisms, such as fruit flies, to see how the conditions of space affect life. And just at the start of the year, taikonauts successfully tested a technology that brings oxygen recycling and the need for in situ rocket fuel together. In the first experiment of its kind, using a semiconductor catalyst, taikonauts on Tiangong produced oxygen and hydrocarbon ethylene out of carbon dioxide in an instance of artificial photosynthesis. Hydrocarbon ethylene can be used to make rocket fuel, but researchers also believe they could use the same process to make methane, formic acid, or even sugars, mimicking what plants do on Earth. This discovery is groundbreaking. On the ISS, the electricity required to recycle oxygen using electrolysis techniques is thought to take up a third of the ISS's energy usage. This new process is more efficient, gets rid of the CO2 being breathed, and can be done at room temperature. That's an incredibly useful technology to have on any long-distance space mission. Finally, taikonauts are testing their gear to make sure it works in space. This is the last of the 5 research themes, and while not as flashy as the others, it's a vital step in the process, and one that's difficult to replicate on Earth. The unique conditions of microgravity can put a lot of different strains on machinery. For one example, fluid dynamics are much harder to currently model, for another. And if you want to solve these things, it's practically impossible to replicate microgravity if you're deep within our gravity well. Putting it all together, it becomes clear that China is already thinking very carefully about not just a lunar base, but a vast network of habitats across the solar system, self-sufficient, able to mine resources wherever they are, and with the manufacturing capabilities to construct parts or whole new spacecraft out of it. With this infrastructure and technology in place, China will be able to mine resources from asteroids across the solar system and set up human presences on countless moons or planets. Yes, it's still early days, and it's not like China is alone in this, but it's a sign of how far things have progressed. If China is testing out the technology to build manufacturing bases in space, the platforms themselves can't be that far behind. To be clear, China isn't trying to be secretive about any of this. In fact, the Chinese are very in favor of collaboration. However, under American law, American astronauts are not allowed on board Tiangong without express permission from Congress, something not likely to be given. And although Europe initially planned to collaborate with China, they pulled out in 2023, citing insufficient budget and no political green light. Although European and American nations are wary of it, China has invited scientists across the world to perform joint experiments on the Tiangong station in a spirit of international collaboration and mutual benefit. It remains to be seen whether other nations will join China in these experiments, or whether taikonauts will be doing these thousands of experiments on Tiangong alone. Artificial photosynthesis, orbital construction facilities capable of building a space rocket, robotics, in situ rapid growth of food, new power sources, new propulsion. All in all, we are entering into a new stage of space exploration. To date, the furthest a human has ever traveled from our home planet is our moon. We've set foot there, looked around, but soon came home again. China's experiments on Tiangong are signs that a new approach to space is fast arriving, one where humanity does not simply go to space to come back again. We as a species are well on the way to leaving the nest of our Mother Earth and spreading our wings to fly out and discover new territories, further and further onwards from there. I hope we are ready for all that entails. Well, that's all we have time for today. If you've enjoyed what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.